Z parameters are otherwise called as open circuit impedance parameters. So here first point is, so we have to draw the block diagram of two-port network. So this is the block diagram of two-port network. It has two ports, and port 1 voltage is V1 and current is I1, and port 2 voltage is V2 and current is I2. So this is a general block diagram of two-port network for any parameters. And coming to the Z parameters, so Z parameters means, so port voltages as a function of current. So we have to write Z parameter equations such that port voltages, so V1 and V2 are the port voltages and I1 and I2 are the port currents. So port voltages as a function of port currents. So V1 is a function of I1, I2, and V2 is a function of I1 and I2. So V1 equal to, we can write like this, V1 equal to Z11 I1 plus Z12 I2. So first equation, and V2 is Z21 I1 plus Z22 I2. So this will be the second equation. So where here this constants, so this coefficients, so Z11, Z12, Z21, Z22 are Z parameters, and again where Z11 is input driving point impedance and Z22 is output driving point impedance, and Z12 is reverse transfer impedance, and Z21 is called as forward transfer impedance. So now, so this is in second point, so I am writing just Z parameter equations, and first point it is a block diagram. Now our purpose is to solve this for this Z parameters. So we have to get this Z11, Z12, Z21 and Z22. So that is the third point. So third point is solving for Z parameters. So for solving for Z parameters, so here we have to make I2 equal to 0 to get Z11 and Z21, and we have to make I1 equal to 0 to get Z12 and Z22. So if we make I2 equal to 0, we get two parameters Z11 and Z21, and if we make I1 equal to 0, we get the remaining two parameters Z12 and Z22. So first I am taking I2 equal to 0. So if you make I2 equal to 0, equation 1 becomes V1 equal to Z11 I1, which in turn Z11 equal to V1 by I1 ohms. So similarly equation 2 becomes V2 equal to Z21 I1. So from that one Z21 equal to V2 by I1. So V1 by I1 is Z11 and V2 by I1 is Z21 when I2 equal to 0. So similarly, if we make I1 equal to 0, we get the remaining two parameters. So equation 1 becomes, so for I1 equal to 0, equation 1 becomes V1 equal to Z12 I2. So from this one, Z12 equal to V1 by I2. So voltage to current ratio, so the unit is ohms. So similarly, equation 2 becomes V2 equal to Z22 I2. So from that one, Z22 equal to V2 by I2 ohms. So if we make I1 equal to 0, we get the remaining two parameters Z12 and Z22. So Z12 equal to V1 by I2 ohms and Z22 is V2 by I2 ohms. And next point is, the Z parameters are also called open circuit impedance parameters. The other name for Z parameters is open circuit impedance parameters. Why it is called as open circuit means each time we are making current 0. So if you make I2 equal to 0, we are getting two parameters, and by making I1 equal to 0, we are getting the remaining two parameters. So that's why it is a open circuit, as we are making current equal to 0. And circuit impedance parameters. So impedance parameters, so each parameter is a voltage to current ratio. Voltage to current ratio is impedance, so that's why they are called as impedance parameters. And now we have to check whether the given two-port network is reciprocal or not. So reciprocal and non-reciprocal networks. So a two-port network is called reciprocal if the open circuit transfer impedances are equal. That is, if Z12 equal to Z21, a two-port network is reciprocal. So based on the Z parameters, we can say whether the given two-port network is reciprocal or not. If Z12 equal to Z21, so we can say the given two-port network is reciprocal. So generally reciprocal means, so networks containing resistors, inductors and capacitors are generally reciprocal. So networks containing dependent sources are generally non-reciprocal. So if the two-port network has only resistors, inductors and capacitors, generally so resistors, capacitors and resistors, inductors and capacitors, definitely we have to get Z12 equal to Z21. If there are any dependent sources in the two-port network, then it is a non-reciprocal network. At that time, so Z12 is not equal to Z21. If Z12 equal to Z21, the given two-port network is said to be reciprocal. So similarly, symmetrical networks. So sixth point is symmetrical networks. We have to say whether the given two-port network is symmetrical or not. A two-port network is called symmetrical if the open circuit driving point impedances are equal. That is, if Z11 equal to Z22, a two-port network is symmetrical. So similarly, based on the Z parameters, if Z11 equal to Z22, given two-port network is said to be symmetrical. So next point is Z parameter equivalent circuit. Now we have Z parameters. So based on the Z parameters, we have to draw Z parameter equivalent circuit. So to draw Z parameter equivalent circuit, we are drawing a diagram. So to satisfy this equation, so V1 equal to Z11 I1 plus Z12 I2 and V2 equal to Z21 I1 plus Z22 I2. So V1 equal to so Z11 I1 is a voltage and Z12 I2 is a voltage. So here voltage Z11 I1 voltage plus Z12 I2 voltage is equal to V1. So if you draw the diagram like this, so V1 equal to Z11 I1 plus Z12 I2. So already I1 is there from the port 1. If that I1 is multiplied with Z11, you get Z11 I1, which is a voltage. Second voltage is Z12 I2. So Z12 I2. So I2 is the port 2 current. So that's why I am taking a dependent voltage source to satisfy this term Z12 I2. So Z11 I1 plus Z12 I2. So together is equals to V1. In similar manner, so second equation. So second equation is V2 equal to Z22 I1 plus Z21 I1 plus Z22 I2. So here when Z22 is multiplied with I2, we get one component of V2, and when Z21 into I1 is the second component of V2. So here V2 is the port 2 voltage, I2 is the port 2 current. When I2 is multiplied with Z22, we get one term, one component of V2, so Z22 I2, and second component is Z21 I1. So I1 is a port 1 current. So that's why to satisfy the term I am taking a dependent voltage source. So whose value is Z21 I1. So in that way it becomes the Z parameter equivalent circuit. So given two port network and this Z parameter equivalent circuit, performance point of view, they are same. So here, so similarly, we can draw T equivalent circuit for the given two-port network. So a reciprocal network may be modeled by its T equivalent circuit. So first of all, we have to check whether the given two-port network is reciprocal or not. If the given two-port network is reciprocal, then we can draw its T equivalent circuit. So based on the Z parameters. So let's suppose this is the T equivalent circuit for the given two-port network. So ZA, ZB, ZC, which is in the form of a T, and V1 and V2 are the port voltages, and I1 and I2 are the currents. So it is in the form of a T. So that's why it is called as a T equivalent circuit. So once after getting Z parameters, based on the Z parameters, we can get T equivalent circuit. Now we have to write what is ZA and ZB, ZC in terms of Z parameters. So here if it is I1 is the current in ZA, and I2 is the current in ZB, and current in ZC is I1 plus I2. So ZA, ZB, ZC are the T equivalent circuit impedances. So if you write KVL in KVL in loop 1, V1 equal to ZA I1 plus ZC I1 plus I2. If you write KVL here, V1 equal to ZA I1 plus ZC I1 plus I2. So here V1 equal to, so if you write all the I1 terms at one place, ZA plus ZC into I1 plus ZC I2, let it be third equation. So similarly, if you write KVL equation for loop 2, we get V2 is equals to ZB I2 plus ZC I1 plus I2. So V KVL in loop 2. V2 equal to ZB I2 plus ZC I1 plus I2. So V2 equal to, so Z2 I1 terms are ZC I1 plus I2 terms are ZB plus ZC into I2. So let it be equation 4. Now let us compare equation 1 with equation 3 and equation 2 with equation 4. So equation 1 and 2 are, so these are the Z parameter equations, equation 1 and equation 2, and equation 3 and equation 4. So these are the equation 3 and equation 4. So comparing equation 3 with equation 1 and equation 4 with equation 2. So we get, so Z11, so Z11 is equals to ZA plus ZC, Z12 equal to ZC, Z21 equal to ZC, and Z22 equal to ZB plus ZC. So here all the Z parameters are as a function of ZA, ZB, ZC, but we want ZA, ZB, ZC as a function of Z parameters. So here we can write ZC equal to Z12, which is equal to Z21. So ZC equal to Z12 equal to Z21. So Z12 equal to Z21. So this happens only for the reciprocal networks. So if the two-port network is reciprocal, then only we get this Z12 equal to Z21. So here ZC equal to where the impedance of the T parameter, T equivalent circuit. So ZC equal to Z12 equal to Z21. So similarly ZA. So here from this equation, ZA can be written as Z11 minus ZC, and ZB can be written as Z22 minus ZC. So ZA equal to Z11 minus, so for ZC I am taking Z12 ohms. So similarly ZB equal to Z22 minus ZC. So Z22 minus, so for ZC I am taking Z21 ohms. So in that way, so these are the values of ZA, ZB, ZC, ZA, ZB, ZC of the T equivalent circuit as a function of Z parameters. So ZC equal to Z12, which is equal to Z21 ohms, ZA equal to Z11 minus Z12 ohms, and ZB equal to Z22 minus Z21 ohms. So this is the theory part of Z parameters.